Hello, my name is Dennis, and I'm making this video to introduce you to the FactFrame project. And before I do that, let me walk you through my reasoning and my background so you understand what is the problem that we're trying to solve here. So I've been an electronics design engineer for about 4 years, and when ChatGPT came out, I actually didn't notice any difference in the way I work. So it is barely helpful with electronics. It can give you some generic advice, but it never gets the actual job done. It can also do some calculation, but you never trust in the calculation. So is there even a point in using it? It's getting better at the moment, but still, if you compare what you can do for electronics compared to what you can do for programming, it's night and day. Like in programming, LLMs at the moment are already bringing incredible value and automating some processes, making you more efficient, making you being able to do more. And I think there is a potential in LLM to do a lot of help for electronics as well, but it's just the tooling that we use is very hostile to the LLM interface, which is text. And if we have to think about how do you make electronics design LLM friendly, we need to convert basically everything to text. And I want to make a shout out to JTX project. I don't know how to pronounce it correctly, maybe GITX, whatever. And what they did is they made a Visual Studio plugin where you can code and generate a schematic from the code. So you have electronics libraries in the code, you have the schematic and the PCB in the text format, like here. And because of that, it is possible to use AI to generate such designs. It is in a sort of demo, right? It is possible to design with, but I don't think it's commonplace. Like it's not the tool that you will obviously use if you start electronics design, but I think this might be the future because electronics design has to become text-based. But now there is another thing. It's not only the design itself. When you are making the design in electronics, everything you do is based on datasheets. And I just pull up whatever random datasheet is here. And you obviously all know that it is a PDF file. So even if you are creating a library in JTEX, you are taking the data from the PDF file by looking at it. In many applications, you need to do a lot of documentation before you commit to the design. Like the cost of mistake is huge. And whenever you write any test spec or the calculation, you always take the data from the datasheet and you enter it manually in whatever tool you're using. I frankly think this is embarrassing in 2025 to do something like that, to have an engineer look up the number and type it in some other tool, but this is the way things are. And so I prepared some basic reasoning on how to get around it, how to actually try to solve the problem. And this might not be the best solution, but this is what I thought of. So we have the original PDF document, which is the datasheet in our case. And then in order to use it in any calculation or like, let's say math package or some document, or to use it with LLM, like let's say ChatGPT, you cannot use it directly. You need to parse it first to some text format. And so like at the moment, what you do, you just parse it with your eyes and then enter it here manually. That's what you do. If we want to automate this, we first have a parsing step, and then we generate some more common sense file format out of the PDF. And in my opinion, there is a big room for improvement. I think the markdown should be the way to go. I see some manufacturers right now introduce like web-based datasheets, but they are not really that useful. I found myself using the PDF more often anyway, and everybody does it different still. So what I think would be nice to happen if the industry could agree on some standard format, which is machine readable first of all, for collecting the data for each component type. Of course, you can have special section then, and you describe whatever special parameter you have, but there has to be some commonality shared throughout all the suppliers. And I think there is a potential in this entire project to cover some of that, to actually have a parsed datasheets library and then try to work on the standard. But this is not what we're focusing on right now. This is just one part of the equation. Then if you would have a library of such parts, you could directly draw from, let's say, API, or if it is just a file, you could directly import it to your math package. You could directly use it to pull in some algorithms, like say Python or something, and then you can reasonably expect that this is accurate. So in red, I'm showing the error, the steps that can introduce error. And yes, when you go from PDF to parsed variant, you may introduce error, but then if you have library, you sort of mitigate that problem. And so then you can use this data without error in some algorithms, and it's fine. But then there is a whole realm of another applications where you use LLM to post-process it. So you may want to chat with your datasheet, like, ask some questions. You may want to maybe compare some parts. You may want to generate some documentation by yourself. Maybe you want to generate the library part, right? And so you just throw the text file into the LLM and you expect another text file back, and then you use this text file to get the library component, and maybe you get all the properties filled in. Like, you can do many things. But then if you get the response back, you can have a risk of introducing the error again. Why? Because LLM can hallucinate. You cannot guarantee that all of the data it has been taken from here. It may just put whatever random data in the answer, I mean. And so then again, you have a need to check with the source of truth, because like cost of mistake is very high. And often, even if you do the design yourself, like maybe you do the calculation or something, you would then throw the screenshot of the original datasheet just nearby your variable definition, just because you want to double check where you have taken it from. And so I thought of a solution that may solve this problem, maybe partially, maybe fully, and it can actually be reasonably useful in other areas. So I call it FactFrame, which is a frame of the source of data, basically. So whenever you have a response, you click on it and you get your source of data shown to you, where it has been taken from, exactly. It's like a screenshot. So it's not like when you use retrieval or augmented generation and it says just, oh, I referenced that document and somewhere. No, this is exactly the place where it's taken from. And I think it may be actually useful not only in electronics, like if you are in legal or some other area where the cost of mistake is really high and you better exactly find where the info has been taken from. Maybe that technology would be useful. But today we're focusing on electronics. And so the feature that I wanted to use to demonstrate the technology to you is the parts comparison. It can be obviously expanded beyond that. I just wanted to limit the scope so that the task is actually solvable in a reasonable time. So then when I click on the button on the landing page, I get to the actual application. So from here, let me start the guide through the actual application. You have a sign up form here. So you can enter username, email, password, sign up. I already did that. So let me just sign in to my account. Let me grab the credentials. And generally, I would be looking forward to get some comments under the video and general feedback, because I want to understand where to move it forward. And I have multiple ideas, but whenever I get more people think on the issue, we can think of better solutions. So I already uploaded 2 documents here. This is the homepage, and then the interaction with the app starts with my documents section. Here you can upload documents, which is, in my case, I uploaded 2 simple data sheets of 2 transistors. So you would select the part, then you would enter the title, select the part type and the part number, and you would upload the document. Next thing you do is you would extract it. So this is basically the parsing step. That's what you do here. And I already have done that. It takes like a minute or two. And then after the extraction is done, you can click on details, and inside you will see the actual extraction result. So this is in my case the markdown file that we were talking about. And this needs a lot more improvement than it is at the moment. It is just a very raw proof of concept solution of the extracted file. And we have been focusing on quality extraction of the tables. So I could have used some open source tool, but instead I went with the closed source off-the-shelf solution so that I can extract the tables as accurately as possible. I tested multiple of them, and that seems to be the best one from my testing. And the useful feature at the moment in this window would be to download the Excel file. And if you do that, this is what you get. So you already can get quite usable Excel file with all the parameters. So like the tables from the actual datasheet. So if you need to make some document or like test spec and you want some values from the datasheet, you don't need to manually copy and paste them. You can just copy the entire table if you need this table. So this may be useful to automate some of your work, to just help you quickly. And then this markdown file is something to be developed further if we want to actually make it a standard format that is digestible for the LLM. This is like a ton of work to do. But then there is an actual use already. It is in creating comparisons. So you can select two parts of the same type, which is in this case transistor, and the tool will allow you to create comparison. So the comparison is done, and you can already export it to Excel and use it for whatever purposes you want to. But before you do that, you would really want to check for any possible errors in parsing or LLM processing, right? Because the cost of making a mistake in electronics is quite high. And so we can actually demonstrate the FactFrame technology in here. So let's say the drain current, I want to inspect where it's coming from. And so I click on that and I get the table from the actual datasheet that I have uploaded and parsed, where it's been taking the value from. So in this case, it highlighted a bit off, but the table is correct. It is drain current and the maximum value is 350. So it says the drain current 350 milliamps. And then in the other datasheet, the highlight is again a bit off, but the actual maximum drain current continuous is 280, which is also correct. So I can say this is confirmed, and I can say that this is confirmed, and both of these values are accurate. At least they are matching the datasheet, right? So this obviously can be expanded with like minimum, maximum, typical. This can be much more complicated than this, but we're trying to keep it as simple as possible to have it as a proof of concept. And so after you go through all the values, like let's say the power, right, for 50, so for 40, right, for 40 milliwatts, you can confirm that as well. Or if you are comparing, let's just say that you are comparing this single-sided copper. So you wanted to have 370 here instead for some reason. Or if it would make a mistake in parsing, what you could do is you could click on edit and you can modify this value to 370. And now 370 is going to be displayed in comparison, and you will see this is the edited value. So you can go through, like, for example, ambient temperature, right? It says not specified, but I'm pretty sure it is. Oh, actually it isn't. It only says the storage, which is not exactly the same. But let's say we want that. So we want to specify from -65 to 150, right? So we want this value. Let me copy that. And instead of not specified, I'm going to put here the value I want and save that. And so when I go through all the values, I can be assured now that they are matching the original document. So they are actually all coming from here, and I have image that confirms that. And now when I'm comfortable, I can export this comparison to the Excel and use it for future like reviews by engineers, comments, making a decision, is this alternative suitable or not? Depends on what you want to do. So now let me try to open this Excel. Okay, and if you open this comparison in Excel, this is what we actually get. So we get the username who made the comparison. We have the info, was it checked, was it not? And the values for the parameters. And here we also have the same data with images. So these are the images of the source files. You can see the highlights are not exactly accurate at the moment. This is to be worked on. And these are the same parameters and where it was taken from. So it's like datasheet and then table and raw, where it was taken from. Okay, so hopefully this can be useful for any of your application already. And then I'm looking forward to getting feedback on my general vision on how to make the electronics more accessible to LLMs, basically. How to solve this problem of using the PDF documents. I would call this the datasheet problem. Yeah, so let's maybe think together on how do we solve the datasheet problem. The next things I would imagine doing is enabling chat with the component. So you would upload the datasheet, extract it, and then you can have a chat interface when you're asking questions. And then when you get responses, you can actually click and double check, oh, this is actually correct value. And another thing I would like to do is adding footprints in here. All manufacturers are notoriously specifying footprints in different names. So it needs to be harmonized, at least for comparison reasons. That would be very useful. And then the comparison functionality would be extended by microcontrollers. So for them, pin assignment comparison and features comparison is very important. So there are multiple areas to expand on. Also the document itself, this view, to be improved. But at the moment, if you find use in this, we are limiting your possibilities only to 10 documents, but overall it's free. It's just because we are paying for the extractions, we are paying for the comparisons, and if you want to support us in this and support the project, we would encourage you to update. It's at the moment there is no payment option, so you basically just contact us and then we will figure it out how to make it work for you in unlimited mode. So if we get more interested people, we definitely make it more streamlined for sure. And we would define what areas to work on together with the customers. But at the moment it is what it is. And I was happy to share it with you. I'm really looking forward to get some feedback from angry electrical engineers who are doing some mundane work of copying and pasting from the datasheet day to day. And actually, I would be very happy to make your life easier. So that's it for the video. Thank you for watching.